Hello everyone, let's talk about trig graphing. So we're going to start to graph sine and cosine functions, and the first day we're just going to look at how we can stretch it out vertically, how we can do dilations, and how we can condense it horizontally, do dilations. So vertical and horizontal dilations. Let me show you in Desmos some of the ideas that we're going to hit today, and then as we start to actually do the algebra, hopefully this helps you kind of visualize what we're talking about. It says a times the sine of bx. The a number, the number that comes in front of the sine or cosine function we're graphing, is called the coefficient, tells you the amplitude. Watch what happens when I make this a value bigger than 1. Right now it's 1. I'm going to change the slider so it gets bigger than 1. Watch what happens when I make it bigger than 1. See how it stretches it out vertically? So if you make it bigger than 1, I'm going to make this a little bit bigger. It stretches it out vertically, and if I say like 3.3, what's happening is the biggest y value is 3.3. 4.2. The biggest y value is 4.2. Same thing out here, negative 4.2. So the amplitude stretches it out vertically. Notice how the x is not changing. Pi and 2 pi are staying the same. As I do this, those are still at pi and 2 pi. So I'm just stretching it out vertically. That's called the amplitude. The amplitude is the distance from the midline, which in this case is the x-axis, the midline to the maximum, or the distance from the midline to the minimum. And if you look, it's the number that is in front of sine or cosine. It's the coefficient. You might notice that it's in absolute value bars, and the reason why is when we say the amplitude, since we're measuring a distance from 0, it's always a positive number. The negative will affect the graph, but the amplitude is always a positive number. I'll show you what happens when you make it negative. So right now, the biggest y value is 10. Watch what happens when I make it negative. It flips over. See how it flips over? So instead of going up first and then down, this one goes down first and then up. And we'll talk more about that as we get there. But the first idea is the amplitude changes the height of it above and below the midline. The b value, if you make this guy, I'm going to put this back to 1. If you make this bigger, the b value is going to do something along the x-axis. Watch what happens when you make it bigger. Okay, so it starts to squish it. The bigger the b value is, you can think of it as going faster. So that's maybe a good way of describing this. Right now, it takes, if you look, 2 pi. The period of this function is 2 pi. So it goes up, and then it goes back down, and comes back to its starting point right here in 2 pi. That's called the period. If I make this b value twice what it was, so it's twice as fast, now it's 1 pi. So hopefully you realize if you do something twice as fast, it takes half the time. So by making this value bigger, it's going to take less, if you think of the x-axis as time, less time to do one cycle. Okay? And if you make it way bigger, it gets way faster. And if you make it smaller than 1, it does the same idea, but it stretches it out. So if I make it like 1/2, if you go half as fast, it takes twice the time. So instead of 2 pi, 2 pi is only halfway, it takes 4 pi. So this is affecting the period. So these are vertical and horizontal dilations. The a value stretches it out vertically, and the b value stretches it out horizontally. Okay? Now let's actually graph some, and we're going to use Desmos to help us. We're just going to have to understand what all of these things are doing so that we're able to use Desmos to help us. So the first one says 3 sine of x. So I'm going to go to Desmos, and I'm going to type in 3 sine of x. That's right here. I already have it typed in. 3 sine of x. Okay, so the first thing I want to look at is how is this affecting the x and the y-axis? And the easy one is on the y-axis, you see the biggest y value is positive 3 right here, and the smallest is negative 3. So since I can clearly see the amplitude is the coefficient, is 3, I'm going to put 3 right there, and I'm going to go to my y-axis, and first I'll label that with 3 and negative 3. Okay, that's the first thing I'm going to do. The second thing I'm going to do is put 4 tick marks on the x-axis. Every problem will always have 4 tick marks. There are 5 places that we care about. The start, the max, back to the midline, the min, and then back to the midline. That's your cycle. So those are the points that I want. But I'm going to look at my graph, and we're going to have to first figure out what the period is. And you can see the period is from the start to the next time it is at the start is right there is 2 pi. The period is 2 pi. Now there's a formula for this. It's 2 pi divided by whatever the b value is. So the b value in this problem is 1. So 2 pi divided by 1 gives you the period of 2 pi. That's why the period is 2 pi. So I will label that guy. In a second, I'm going to label all my x-axis. But the other thing I want to do in Desmos is I want to find what each tick mark is worth. And the step is 1/4 of whatever the period is. So whatever this is, divide by 4. Whatever the period is, you put over 4. And now I'll reduce that fraction and say pi over 2. 2 over 4 is 1/2. So pi over 2 is my step, and I'm going to go to Desmos, and I'm going to click this wrench right here, and when I go to step, I'm going to type pi over 2. Okay? And notice what that does on the x-axis. Now it labels it for me. So when I want to find these values, it's got it labeled on the x-axis. The first tick mark that I'm going to put is at pi over 2, then pi, 3 pi over 2, and 2 pi. So pi over 2, pi, 3 pi over 2, 2 pi. You might remember those are the quadrant angles. Those are the x and y axes, and that's because there was no period change. So the last thing I got to do is just make sure I plot those points. Pi over 2 is at 3 and 0, 0. So we'll start here, 0, 0, and then pi over 2 goes to its maximum. Then we go back to the midline, to its minimum, back to the midline, and then we draw a smooth curve. Okay, there should be nothing that looks like it's a straight line here. It's always moving. So do your best, try and hit your points. That's your graph for the function 3 times the sine of x. We're going to use Desmos to help us, but if you don't know what all those things are doing, then you're not going to be able to work backwards. So we'll try another one, 4 sine of 2x. 4 sine of 2x. And I'm going to use Desmos, and remember, if you hold down the shift key on the x and y axis, you can rescale. See how I hold down, when you hear that click, that's me hitting the shift key. As long as you're hovering over that, it makes it so you can pinch this thing, sort of like you have a touch screen almost. Okay. So 4 sine of 2x. Let's analyze it first. The amplitude is the a value, that's 4, and the period is supposed to be 2 pi, but in this problem there's a b value, so 2 pi over 2 makes the period 1 pi. And if the step is always 1/4 of that, I take the period and I put it over 4. So let's look at the graph and see if this stuff is all lining up correctly. The amplitude is 4, yeah, that's 4 above the midline, that looks good. The step, well, the period is supposed to be pi, so you can see I've got my tick marks and they end at pi, so that's good. And then the last thing for my step, I always want to practice doing this, I'm going to put pi over 4. So you can see now that pi over 4 is labeling the maximum. So I have my 5 points that I want to plot, I just have to draw it. Let's start with the y-axis. On the y-axis, the biggest value is 1, 2, 3, 4, that's 4, and the smallest is -4. Put your 4 tick marks, doesn't really matter how you space them. But it's pi over 4, and as you get better at this, you might not need to keep looking. This is 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4. 2 over 4 is 1/2, and 4 over 4 is 1 whole. Now, I put my 5 points, my start, my max, back to the midline, my minimum, back to the midline. Best you can. It's real tough to do with this thing, but that's pretty good. There you go. Okay, good. There's my sine function. Let's do a couple more. Oh, we'll do a cosine function. All right, so first thing, the amplitude is 2. Great. The period is supposed to be 2 pi, but in this problem there's a b value, so it's 2 pi over 3. And now watch me get the step. 2 pi over 3, and I'm going to do 1/4 of that. I'm still dividing by 4. Dividing by 4 is the same as multiplying by 1/4. Think of it as multiplying by the reciprocal. So when you multiply 2 pi times 1, you get 2 pi, and 3 times 4 is 12. This reduces to pi over 6. Okay, so it's good to have some idea of what this thing's going to look like, but now we'll use Desmos to help. But we got 2. Okay, good. So the y-axis, ooh, it starts at 2 in this one. That's because it's cosine. The period, so if it starts at the top and then I go the next time it's at the top, is it 2 pi over 3? I said it'd be 2 pi over 3, so that's good. And then the last thing is for my steps, I want to make sure I put that as pi over 6. Oh, I got to zoom in a little more. There we go. So now you can see it hits pi over 6. So for cosine graphs, notice it looks a lot like a sine curve. These are both sinusoidal functions. So a sine function would look like that, where it starts on the x-axis, and then it goes to the top, and then it comes back. Sine functions and cosine functions are just a phase shift away. So we're just saying, hey, the cosine at the y-axis, it actually starts at its maximum. So when we graph this, we're going to put our first mark, let's see, I'll put this at 2 and -2. I don't care that these aren't, I'm labeling them however I want. I don't care that it's 3 tick marks. 1, 2, 3, 1. I always like them to look pretty much the same. But you can tell on the y-axis, the biggest is 2, the smallest is -2. And then I'll label my x-axis at pi over 6, and 2 pi over 6 is pi over 3, pi over 3. 3 pi over 6 is pi over 2. And then 4 pi over 6 is 2 pi over 3. Okay, I'm trying to count with fractions, but we're going to use Desmos to help us. So remember, cosine starts here at the top, then it goes to the midline, and then it starts to look like a normal sine function. So a smooth curve. My suggestion for cosine is draw the tails for it turning around, and it makes it more apparent that it's turning around because this is one of those maximums. Again, this is a sine function that's just starting in a different place. It would look like that or a sine function. Okay. Let's do one more. 3 sine, 1/2 of x. So it's like slowing it down. 3 sine 1/2 of x. Okay, so I'll do the analyzing algebraically first. The amplitude is 3, because it's 3. The period is supposed to be 2 pi, but 2 pi divided by 1/2, copy, change, flip. 2 pi times 2 over 1 is 4 pi. So a way of thinking about this is if you do something at half the speed, it takes twice as long. So instead of taking 2 pi, now it takes 4 pi because it's half the speed. And then the step is supposed to be 4 pi. We always put that over 4, so that means we're counting by 1 whole pi. Let's put the y-axis. If the amplitude's 3, I should be going up and down 3. 1, 2, 3, 4. If the step is pi, I should be able to just kind of count by pi. 1 pi, 2 pi, 3 pi, 4 pi. Let's look at it. 3 sine 1/2 x. I'm going to go here to step and make the step pi. And you can see now 0, 1 pi is at 3, 2 pi is at 0, 3 pi is at -3, and 4 pi is back to 0. So you can see my sine function looks something like this. 0, 0, pi is at 3, back to the midline, minimum, back to the midline. Okay, so you draw, again, smooth curves. If you turn in something that looks like this, I'm going to be like, that's not what a sine function looks like. Do better, okay? So you can use Desmos to help you with your x and y axis, but you do need to understand what the amplitude is doing to the graph and what the period is doing to the graph. So go ahead and try your practice problems and make sure you smash that like and subscribe.